My name is René Serrat, and in this demonstration we will present a viable solution to the IS path hijacking problem present in BGP. Our solution uses the path state protocol overlay. To this end, we will use the testbed shown in the figure at the bottom left-hand side of the screen. In the figure, the arrow lines represent client-provider links, while the simple lines stand for peer-to-peer links. In the following demonstration, we will visually show how the path state protocol overlay is able to avoid an IS path hijacking attack by a faked advertisement coming from IS1, faking the incorrect advertisement of IS5. In the demonstration, we will stream a video from IS2 to IS5. Then, while the overlay is actively inspecting the BGP messages, the video will continue to be played at the real IS5. Afterwards, we will disable the overlay message inspection and the video will be forwarded to fake IS5, which we will visually observe as the video will shift to the right-hand side video player. It is important to notice that all this message inspection is totally decoupled from BGP, without any extension or modification in its internal functionality. The first step that we will execute in order to show this demonstration is to start the video streaming from IS2 going to IS5. So now the streaming is working. The next thing is to connect to the fake Autonomous System 5 in order to show its internal configuration, which is the same as the real IS5. We connect to the router to the BGP process there. We enter in enabled mode to show the running configuration. Now we take attention in the prefix 74.133.4.0/24, which contains the host that we are streaming the video to. Now we will disconnect from this router and we will connect to the IS1, which is the autonomous system willing to hijack the traffic going to the real IS5. To do this, IS1 will accept this fake IS5 as a valid neighbor. So now we configure the router. This is performed by entering in configuration mode and then executing the router BGP command line. Once this is done, we just configure the router to accept this new IP as a valid remote IS number 5. The next step will be to configure the advertisement interval to 30 seconds. And finally, to configure the soft preconfiguration of inbound traffic. Once this is done, we have router 1 accepting the routes announced by this fake IS5. So now we just perform a soft restart of the BGP process in the router to accelerate the update advertisement period. Once this is done, at this point the video should stop. In regular situation, the video should stop and start playing at fake IF5. But since we are using the path state protocol overlay, we can avoid this hijacking. To show this, we connect to the path state protocol daemon in IS2, and here we will be able to observe within the statistics as the overlay was able to remove the offending updates. As you can see here in the statistics, we removed 4 updates and removed 1 withdrawal, which was actually the one that affected the video. If we look at the logs within IS2, we can see that the system is invalidating the invalid IS path 215 because it's not existent in the path state table, which is the set of valid transitions within the topology. After this check, we can disconnect from the router, and the next step will be to disable the path state protocol overlay. The effect of this will be once restarting the BGP process in IS1, the effect will be that the update will be successful because now the overlay will not be inspecting the messages. So now we connect to IS1 and we enter in enabled in privileged mode to perform the soft restart of the outbound messages. This will cause the IS1 to resend all the update messages to the neighbors, and with this what we will obtain is that now IS2 accepts this new fake path because the path state protocol is not inspecting the messages. In short time that takes for the routes to spread out, we will see that the video stops in the real IS5 to go to the hijacked video in the fake IS5 window over here. Now in the window is buffering, and after this buffering now you can see as the video is playing in the fake IS5. Of course, in a real scenario, this fake IS5 could have just forwarded the traffic following the regular advertisements and do this path hijacking in a transparent way, making it unnoticeable by the real IS5 while inspecting the traffic going to that destination by a third party in an illegitimate way. So that's all for this demonstration. Thank you very much for your attention.